Far beyond the warmth of the inner planets, out in the silent, sprawling darkness of the outer solar system, a dim turquoise world turns on its side. It is a place of profound cold, of immense distance, of an almost eerily placid calm. But that calm is a trap, a beautiful lie hiding an environment of unimaginable hostility. If you go to Uranus, you won't come back. This is not a dare, or a challenge, or a piece of science fiction. It's a declaration of physics. A statement of fact written in the laws of the cosmos. Uranus is an ice giant, a colossal ball of hydrogen and helium laced with ices like water, ammonia, and methane. It's this methane in its upper atmosphere that absorbs red light from the distant sun, reflecting back a serene pale blue. It's adorned with a set of faint, dark rings and a family of 27 known moons. But its defining feature is its absurd 98-degree axial tilt. It's a world knocked over, rolling around the sun like a barrel, creating the most extreme seasons in the solar system, with each pole facing decades of continuous darkness or sunlight. And its upper atmosphere is brutally frigid, hovering around 49 Kelvin. That's minus 224 degrees Celsius. A cold so absolute it would shatter steel. But the cold is just the beginning of your problems, because there is no ground to stand on. If you were to descend through the clouds, you wouldn't land. You would simply fall forever. The gas thickens around you, the cold bites deeper, and the pressure begins to climb without mercy. Your journey down becomes a battle against the planet itself. Parachutes designed for thinner atmospheres would fail. Balloons would be crushed and burst. The hull of any vessel would groan under the strain, its structural integrity tested to the breaking point and beyond. The air itself is a poison, a suffocating mix of hydrogen, helium, and methane. There is no oxygen to breathe and no oxygen to burn for a chemical rocket engine. It's an inert, unhelpful environment. As you descend deeper, the atmosphere becomes unimaginably dense, turning from a gas into a supercritical fluid, a bizarre state of matter that's neither liquid nor gas. The pressure becomes crushing, like being at the bottom of an ocean made of air, 1,000 times denser than our own. This combination of extreme cold and relentless pressure creates a perfect, inescapable vice, and this atmosphere is not still. Winds on Uranus approach 900 kilometers per hour, violent jet streams stacked in bands that circle the planet. The boundaries between these bands are zones of extreme wind shear, where a spacecraft could be torn apart by the differential forces. The turbulence is chaotic and unpredictable, turning any attempt at guidance into pure guesswork. In this sky, control is an illusion. You are not flying. You are being carried away by a planetary-scale storm. Lightning may crackle through the methane and ammonia haze, supercooled droplets flashing the dark with ephemeral light. Deeper still, the physics becomes truly alien. Scientists theorize that below the clouds, immense pressure and heat could forge an exotic, superionic layer of water and ammonia, a substance that is simultaneously hot, dense, and electrically conductive. And even deeper, the pressure on methane could become so intense that it breaks down, squeezing carbon atoms into solid crystals. A rain of diamonds, falling through the planet's deep interior. This is a world governed by alien physics that laughs at human hardware. Go far enough, and the distinction between sky and sea completely dissolves. Molecules pack so tightly that the atmosphere becomes a dense, slushy ocean. Chemistry itself changes character under these conditions. You don't touch a surface, you become part of the planet, your vessel crushed and assimilated into the churning, high-pressure interior. Even the planet's magnetic field is wrong in all the right ways to be dangerous. It's not centered on the planet's core, and it's tilted a staggering 60 degrees from its rotational axis. This twisted, offset field wobbles and tumbles as the planet rotates, creating a chaotic magnetosphere. Its warped radiation belts form unpredictable pockets that can surprise any spacecraft with lethal bursts of high-energy charged particles, frying electronics in an instant. And the danger begins even before you arrive. Uranus's faint rings are not just beautiful, they are minefields. Composed of dark, dusty material, they are joined by irregular moons and hidden boulders of ice and rock. One bad encounter at orbital speeds, tens of thousands of kilometers per hour, and your multi-billion-dollar ride becomes a cloud of shrapnel. The sheer distance seals the deal. It's a multi-year journey, requiring brutal delta V, changes in velocity that push the limits of rocketry. Out here, 19 times farther from the Sun than Earth, our star is just a weak, distant spark. Solar panels are useless. Heat is scarce. Power is precious, generated by the slow decay of radioactive elements. Every kilogram of mass is fought for in the design, and there is no fuel depot waiting for you in the dark. You bring everything you need, or you don't survive. Talk is slow here. In this profound isolation, communication becomes an exercise in patience. Radio whispers, traveling at the speed of light, take about 2.5 to 3 hours to cross the gulf between Uranus and Earth. One way. A simple question and answer requires a 5 to 6 hour wait. By the time Mission Control receives a distress signal and says, "Pull up," you've already fallen for hours. Real-time control is impossible. Any explorer, human or robotic, must be completely autonomous. And even if, against all odds, you survive the descent, how would you leave? There is no solid launch pad. There is no free oxygen to use as an oxidizer for your fuel. There is no way to perform staging in hurricane-force air. You would need to invent a new form of propulsion to claw your way back up through that chaos, fighting against immense gravity to reach escape speeds of over 21 kilometers per second. You'd have to do it on a planet that gives you nothing to push against. It is, with our current understanding of physics, impossible. This is why robots must go where we cannot. To date, only one spacecraft, Voyager 2, has ever visited, and it only dared a brief flyby in 1986. Future missions envision an orbiter and an atmospheric probe. These robotic explorers could map the rings in detail, taste the air, and ride the winds on a one-way journey. They would be our expendable, patient, unbreathing emissaries. Humans are none of those things out here. We are fragile. We are impatient. We need to breathe. Curiosity is what makes us brave enough to look out at these distant worlds and dream of going. But wisdom is what keeps us alive. It teaches us to understand the difference between a frontier and a fortress. Some places are for robots, at least for now. Uranus is one of them. It is a world that does not want visitors, and it is exceptionally good at making sure they never, ever leave.